Lightning Talks. I'm your host. My name is Kevin Leduc, and I am the manager of the analytics team. And I am standing in the audience this week. The audience is sparse. We're still walking in, but online, the last Lightning Talk had 100 or so visitors. So the way these works are, this is a chance for an engineering team to showcase a goal that they've reached or a significant milestone. We'll also have time for a couple of interns who participated in the Google Summer of Code to present their, showcase their work. And this week we have 3 presenters. They will each get 10 minutes. After 8 minutes, Megan will speak into the microphone and say 2 minutes left. And she'll say 1 minute left, and then we will move on to the next speaker. So, without further delay, let's start our lightning talks, and Andrew will go first with event logging on Kafka.
Okay, hi everybody. I'm Andrew. I'm an operations engineer on the analytics team. And yeah, I'm going to talk about some work that we did over the summer to improve reliability and scalability of the event logging system. Let me see if I can get this shared here. Everybody can see that, right? Okay, so event logging. So event logging is a system that different teams use around the foundation to gather information about new features they're building or whatever other types of structured analytics data they would like to intake. Originally, this system was built on 0MQ and was built to run as a series of Python processes on a single server. This worked great, but was relatively unreliable. For starters, the messages originated from potentially lossy UDP sources. So, along the network path, it's possible for the messages to just be dropped, and we wouldn't know anything about them. But also, there's no buffering of these messages anywhere in the system. So, when we have to restart a process, or if there was downtime, we would lose messages. And you can see in this diagram here, there's a bunch of those little yellow boxes are all Python processes. And anytime any one of those would go down, while it was down, we would lose all messages. So this is a big single point of failure. In addition to being unreliable, the system was difficult to scale. It was designed to run on a single node, so we were bound by the throughput of a single node, and also each of the processes were only single-threaded. So however much a single core could do was as fast as we could make this thing go. So in our benchmarking, we could only support around 500 to maybe 1,000 messages per second at any given time. And so people were forced to resort to doing a lot of sampling of the data before it would come to this system, which is fine for a lot of cases. Sampling is fine, but there are certain cases where you can't sample if you want to do certain types of analysis. In addition, doing all of this analysis in MySQL is painful at scale. One specific feature of this system is that tables in MySQL were automatically created based on the type of data and the revision of that data. So each data is schema'd and has a revision. So whenever you make an edit to a schema, like add a new field, it creates a new vision, and all of the tables in MySQL are based on that. So every time you added a field to the data, like if you wanted to collect something additional, it would make a new table. This is difficult in MySQL because you have to resort to some like union queries and query across tables to join historical data together. In addition, it's not particularly good with large data. If MySQL can do large data, but if you're trying to do complex queries on large data, it's not so good with it. So those are some of the problems, and we solved a lot of these problems by replacing the 0MQ based backend with Kafka. For those of you who don't know, Kafka is a big, distributed, reliable log buffer. It can also be used as a message queue. We're using it to process and intake the web request logs for all Wikimedia websites, which does an average of around, right now, like 150,000 messages a second, something like that, but can peak higher, and we should be able to scale to much, much higher than that with Kafka. So now that we've done this, event logging is more reliable. The messages go over TCP rather than UDP, so we don't have to worry about just network dropping packets. Kafka buffers all of these events for, by default, 7 days. And whenever these different processes are actually reading this data from Kafka, they commit their offsets of what they've actually read back to Kafka. So that way, whenever we restart them or if there's downtime, they will be able to read those offsets from where they left off and start where they left off. So if a process goes down for a day, that's a problem because we're stalled on data, but we're not losing that data for a whole day. We just have to start the process back up, fix whatever's going on, and it should start from where it left off and reconsume the past day's worth of data. In addition, it's now easier to scale horizontally. So in this diagram, you can see, maybe you can't see, I'm not sure, but the processors here, the one on the top of the bottom, they are the most resource intensive of the system. And we've made it so those are very easy to parallelize. So we're running many instances on a single node. The client-side one where most of the data goes through, we're running, I think, 12 processes right now of that. And this has allowed us to scale just on a single box up to around 7,000 to 10,000 messages a second. And we can also scale approximately linearly. So if we need to handle more than 7,000 to 10,000 messages a second, we can just add more hardware. Takes a bit of configuration to get it right, but there's no coding involved in doing that. We just have to, provision more hardware, configure things properly, start up the processes, and it should just go. Having the data in Kafka means that it's very easy for us to import this into Hadoop. We're importing it as it comes in as raw JSON, and we can query that JSON in the same way that we query our WebRequest logs. It makes it a little bit easier for cross-schema revision processing. I was saying that it was difficult in MySQL because it had multiple tables. Now, because you're just parsing JSON, you can, as long as you're aware and program around the differences in the schema, you can easily query all of the data with a single query. And also in Hadoop, we can handle a lot more data than MySQL. Our Hadoop cluster now is over 30 worker nodes and many terabytes of space. So I'll just gloss over this. If you want to look at these slides later, you can see where the data is being imported. But it's being imported in hourly partitions, so you can query this data at an hour level or larger granularities. And then I'll also gloss over this a little bit, but I've just got a few examples of how you could actually query this data in Hadoop or from Kafka. So here's Hive. It looks a little bit long because I'm creating the table to start with, but really all I'm doing is creating a single string field table, and then there's a function called getJSONObject where I'm parsing particular fields out of the JSON and grouping by it and counting by wiki. So this is the number of edits per wiki on October 21st during the 1600 UTC hour. I'm actually not exactly sure where this data comes from. If there's just an edit schema, I think it's coming from clients. It might just be Visual Editor, but I think it's all in there. This is just a dummy example. So what this actually means, I don't know, but this is how you would get it. In addition, here's the exact same data using Spark Scala. Spark is a distributed processing framework on Hadoop, but it doesn't use MapReduce. It uses its own thing. So there's a lot of ways to do things in Spark. This is using Scala. Here we're using a piece of Spark called Spark SQL, and it allows us to run SQL on certain types of structured data. So it's very similar to the SQL query that I issued for Hive, and then I'm just printing out the results there. This is the exact same, almost the exact same code, but doing it with Spark Python. Same system, it's just that Spark will let you code in Scala or Python. The code is very similar, same kind of SQL query, printing the things out. And then in addition, Kafka is a stream-based system, so we can consume directly from Kafka. We don't have to wait for the batch stuff to go in there. If the data is very large, which a lot of this event logging data is not, it's harder to do like in a single process like I'm about to do, but this data is not large. So I'm going to attempt to do a little live demo here. What I'm doing is I'm using this Kafka cat program, which is a C program to interface with Kafka. And I'm consuming the event logging edit topic, and I'm just summing and counting and printing out the results every 5 seconds. So let's see if I stop my screen share. Share this over here. Okay, you guys can see that. So that's the same thing that was on the screen. And if I run this, it should take about 5 seconds, and then it'll start printing out, sliding like every 5 seconds, the top number of edits per wiki. Yeah, so you can see InWiki had 47 edits in the last 5 seconds. And that's it for me. Do I take questions now?
Yes. Any questions?
Okay, questions.
I have a question.
Okay.
It's a hard. So, who's the first customer to use this or to benefit from event logging? Like, what's the use case? that drove this?
One of the use cases was the discovery team wanted to be able to collect more information about how people were using search on Wikimedia. And when they first came to us, we had to say, sorry guys, we can't really support more than this. You have to do like tons of sampling to figure out what's going on. With this new system, we should be able to support exactly what they want. We might ask them to do sampling just because we don't want people to just hammer the system for no particular reason. Depends on the use case. We haven't, as of yet, as far as I know, worked with Discovery to actually get them to push more data through the system, but that was the original driver for this.
Cool. Thanks.
Mm-hmm.
More questions? There's some chatting on IRC, and I'll speak it so it gets recorded. There's questions about who developed Varnish Kafka. Did WMF write it?
Right. So there are several pieces here that gets this data in. Varnish Kafka is a C interface to the Varnish shared log API, and uses Liberty Kafka. Both Liberty Kafka, which is the C client for Kafka, and Varnish Kafka itself were written by Magnus Edenhill. We contracted him out a couple years ago to write that software for us. A lot of this, I want to mention, I want to thank, while we're at it, Madhu for doing a lot of awesome work with this Python event logging stuff. She did a whole lot of work to make it easy for us to automatically consume and balance consumers and scale this thing. So she did a great job. Yeah.
Cool. Any more questions? No questions. All right. Thank you very much, Andrew. Let's give Andrew a hand. All right. Next up is Tina.
Hi guys. Can you hear me?
Yes, I hear you. Can we see you?
Yeah. Okay. So hi everyone. I'm Tina Johnson, and I'm a GSOC student, and I worked on the newsletter extension this summer. So I think I'll go to the slides. Okay. Yeah. Is it visible?
Yes, we see it. Thank you.
Yeah. Okay. So I was thinking of giving you an overview about the extension, and then later moving on to a live demo. So basically, handling newsletters were not very easy in Wikimedia. So whenever the newsletters were listed, whenever a newsletter was created, it was listed on a wiki page, and it doesn't automatically list the newsletter. So you have to just manually go and add the newsletter. And also, even if you have to subscribe to a particular newsletter, you have to add yourself to a wiki page, and you get a notification on your user page through a mass message list. And also, there was no centralization of the workflow. As in, when you think about newsletters, there are many functions to it, as in subscribing, unsubscribing, deleting, creating a newsletter, and many others. So you would want all these at one place, and this was not there until the newsletter extension came. So so what does the extension do? So what we have done with the extension is that it can handle subscriptions to newsletters very easily right now. And also it provides very user-friendly interfaces to create or delete newsletters, announce, subscribe, and all the functions which a newsletter would want. And also it uses the echo notifications whenever an issue is published. A subscriber gets an echo notification. And so I was thinking I'll move on to the live demo. If you look at it, we have about 3 special pages for this extension. The first one is a create newsletter, and oops, sorry. And yeah, here, so if you see, it's just a simple form, and you can just create a newsletter. You can add its descriptions to the main page, and just like that, you can create a newsletter. And then if you want to see the list of newsletters, you can go to the special page, special newsletters, and you can see how the subscription has changed. If you look at it, this was the older form where if you had to subscribe, you have to add yourself to a new list. Instead, you can just subscribe to a newsletter from just one click away. And then the other function is which is implemented by the special newsletter, the managed newsletter special page, is if you wanted to announce a new issue or maybe add a publisher and anything related to managing a newsletter or even removing a publisher, that's what you do within this page. And also if you go back to the newsletter list and if you click one of the newsletters, you can see the new form where you can delete or manage or subscribe. I get these options because I created this particular newsletters, and if another newsletter is, suppose I haven't created this newsletter, so I only get to unsubscribe. I don't get to delete or manage the newsletter. And that's about it with the demo. And moving back to the slides. Sorry, I think I have a few difficulties here. Yep. So the next slide is about the present and the future of the newsletter. So the extension is not deployed yet. We're still undergoing the design and the technical reviews, and we expect it to be deployed by December of this year, and we hope to see it on Wikimedia. And the future plan involves, inter-wiki support for the extension, and exporting whatever is right now, whatever newsletters we have to the newsletter extension, and also migrating existing new subscribers and many more. But these are the ones we particularly concentrate on. And these are the links. If you go back to the slides, you'll be able to go through the links and maybe join us and do a few contributions to the newsletter extension. And thank you.
Thank you. Any questions for Tina? Yeah. Here, I'll do the mic.
Yep. Yep.
Do you have any sense of how many newsletters there are right now?
How many newsletters are right now in? Oh, this one, the one which I showed you?
Well, I mean, like, I don't know, on NWiki or MetaWiki, or, I mean, how popular are they? Are there dozens of them, or just a handful on each wiki, or?
I think there are quite a few, because once we started with the extension, we got a lot of response saying, that such an extension has been expected for a while, and they've been facing many difficulties. And I think there are quite a lot of subscribers to the newsletters as well. I really don't know the exact number, but I think there are quite a few.
Thanks. Also, what was the hardest part of developing it?
I think the hardest, we didn't find, I had two mentors and they helped me a lot, but we initially faced some conflicts, or there were some developers who were not really interested in the extension, but then after the GSOC period started, we formed an MVP, a minimum viable product, and we set out the very few features that an extension should have. And so until the MVP was formed, it was quite difficult for me to understand what should I start with, or which feature should be implemented first. So once the MVP was done, I was able to get ahead with it, because I got a map, or I knew what to do next. So, and also we had weekly meetings, and so they always help me in deciding what should be done next. And yeah.
So would this extension be available in each wiki project, or would it be on one project and centralized?
Yeah. What initially, right now, we are thinking of deploying it to Wikimedia, as in maybe tested it on one wiki, but definitely we'll move on to the later on wikis. And I told you about the future plans about the inter-wiki support for the newsletter extension.
And what happens if one is subscribed to newsletter across wiki? If you have.
So we thought about the issue, and so as of now, we're not dealing with the issue because right now it doesn't support InterWiki, but we'll definitely try to implement it for the InterWiki support. As in, if a person is subscribed to a newsletter in one wiki and he wants to access from another wiki, we'll definitely deal with that.
Thanks.
Right. Any more questions? All right. Let's give Tina a round of applause. Thank you, Tina.
Thank you.
Cool. And now for our last lightning talk of the day, Divya.
Hello, everyone. Can you see me?
Yes, we can see you.
Okay. Hello, I'm Divya, and I was an intern in Wikimedia for Outreachy program. And what I've worked on is cross-language search tool, that is a translation tool. I'll move on to the slides right now. So can you see the slides?
Yes, we see it clearly. Thank you.
Okay, cross-language translation tool. So what is cross-language search, first of all? Now, it deals with retrieving information that is written in a language different from the language of the user's query. For example, if a user posts their query in English but retrieve relevant documents that is written in French. So, what this tool does is it helps translators to search for messages that is translated in their language. I will move on to the live demo so that we can actually understand what happens. Okay, so this is the user interface for the search tool. Now my user language is Hindi, and I'm doing a query in English, that is edit. When I search for this, I'll get all the messages that contains edit, and not the translated version of edit in Hindi or any other language. So this is called monolingual search. Now this was already there when I started working, but what was not there was cross-language search feature. So I've implemented that during my summer. Okay, so if I search for edit, if my user language is Hindi, I want to retrieve all the messages that have translation of edit in Hindi. So if you go to the next tab, you can actually see the Hindi translation of edit. So what it does is you can query in one language and you can search messages in another language. So this helps translators to maintain consistency between translations. Now I can see some of the words is in different spellings, and translators can just go and modify that and maintain consistency between translations. So this feature was not available earlier. And also, if I want to find all the messages that contain edit in the source language, which has not been translated yet, we can go to the we can move on to the no translation from English tab. So this will list all the messages that has not yet been translated in Hindi, which consists edit. So we can actually edit here, and we can save this. We can also find outdated translations. So all these so we can also find outdated translations, and we can translate. We can actually modify our translations and can save this, and this will become a translated messages. So this is a cross-language search feature that I have implemented. Apart from this, okay, I'll go back to the slides now. So this is something I've given you a live demo on. And now what we do behind the scene. Now a user may pose a query in language A, then it goes to retrieval engine. Sorry. So a user may pose query in language A, and then it goes to retrieval, that is Elasticsearch, and then the Elasticsearch searches the index document and then fetch the document back, and then whatever result it gets in language A, and then the results it gets in language A, it actually go back to the database, and then it fetch the corresponding documents in language B, and then it feeds back the results to the computer, to us basically. This was a cross-language search feature. Now, apart from this, there was a few more features that was missing from the tool. That is wildcard. This is wildcard search. Now, until now, we cannot search with any word that starts with something. For example, wiki, and I want to search for all the words that start with wiki. We cannot do that. We can only find exact words. So what now we can do is we can write wiki asterisk, and we can search for all the words, all the messages that has this word starts with wiki. Now also asterisk cannot be included in the middle of the words. It is not possible. It will just ignore the letters after the first asterisk. Okay. Operators, we already know what is and or operators. So whether you want to search for all the words in the query, or whether you want to search any one of the word in the query. We do not provide an explicit